Hey, welcome to today's lesson. Today's lesson is actually a follow-up to yesterday's lesson. Now, yesterday we came up with these double angle formulas. We found each one of these, the sine of 2u to be that. When we got to cosine, we actually ended up with 3 different formulas. And in our exercises yesterday, it really didn't matter which one of these cosine formulas we used. They all got us the same answer. And yesterday's activities were all based on just manipulating some equations, using some logic to figure out what quadrant we're in, using the Pythagorean theorem to find some missing values, and of course, quite a bit of arithmetic. But today, we're going to learn how to use these formulas when we have to use the formulas. And it's going to be a little bit more important as to which one of these 3 cosine formulas we choose. But the big idea of today is we're going to use the formulas when it's necessary. So let's get started with some problems. Now, you're going to have to pause the video to copy things down. You're going to have to pause the video to try some things out on your own. So do that as much as you need to. Rewind if you have to. But let's work through 4 problems. So this is the familiar solve over an interval. And when we look at this, I see something that worries me. I see that this number, this angle x, is different than that. And I don't like that these 2 angles inside these trig functions don't match up. It makes this really hard and different than anything we've done. We've done problems with the sine of 2x, and we've done problems with the cosine of x, but we've never had a problem where they're mixed. And so I need to make a substitution here that's going to help me solve this problem. I think the sine of 2x can be replaced. And remember, here's that formula, the double angle formula for the sine of 2x. And so I'm going to replace the sine of 2x with 2 sine of x cosine of x. And when I add the rest of this equation in, you'll notice that right now all these variables are the same. Now, this is still a little bit tricky, and it's a little bit tricky because we have sines and cosines mixed together. But if we're clever, I think we can factor this and make this a little bit nicer. Let's not forget that the easiest way to factor anything is to try to pull out a GCF. And since I have 0 alone on one side, I'm going to pull out the GCF, which is 2 cosine of x. It's in both terms. And I'm left with this, and that equals 0. And we know that every single time you multiply any 2 numbers together and get 0, one of those numbers has to be 0. Maybe it's the first, or maybe it's the second. Now, if it's the first, we have to do a little bit of algebra to get cosine by itself. And if it's the second, well, again, we have to do a little bit of algebra to get sine by itself. And we end up getting these values. Now, once we have the trig functions isolated, no coefficients, no exponents, we go to our unit circle. And where in the unit circle is the cosine 0? Well, we know the cosine is 0 straight up at pi halves and straight down at 3 halves pi. And where is the sine -1? Hey, straight down. So we end up with 2 answers. We end up with x equals pi halves or 3 halves pi. And since we're solving over the interval 0 to 2 pi, we're done. And this was all made possible by using a substitution here when we needed to use the substitution. Let's try a different problem. Here's number 2. Why don't you copy this down, maybe pause the video, and see what you end up getting. Well, hey, welcome back. So I hope that you played around with this equation just a little bit. I hope that you isolated the trig value. And I also hope that you just stayed cool. I hope that you didn't panic and immediately jump to the double angle formula for sine, because we don't need it. We have dealt with this this sine of 2x. We've dealt with this frequency change before. This is not a good time to make a replacement. Just keep what you have and go into the unit circle and see what you get. We know the sine is negative down here in quadrants 3 and 4. We know it's radical 3 over 2 at the steep angles. So we get that value and that value. And remember, these values are our angle. And our angle isn't x, our angle is 2x. So 2x is 4 pi thirds or 5 pi thirds. Now, even though I'm solving over the interval 0 to 2 pi, I need to tack this on because I haven't solved for x. So now I can solve for x. Maybe I divide both sides by 2, or probably easier to multiply both sides by a half. And when I do that, I end up getting that x is, what do we get here? We get 2 pi thirds, or we get 5 pi 6 plus n pi. Now again, I had to include this full cycle because we didn't have the x by itself. So I know instead of 2 answers, which the unit circle gave me, I'm really going to have 4 answers because of that 2. So let's add a full cycle of pi to each of these. So x is 2 thirds, add a pi to that, and that's 5 thirds pi. It's 5 sixths, add a pi to that, and we get 11 pi over 6. And that is our answer. Notice, even though we had a double angle, we didn't make a substitution because we didn't need to make a substitution. And this reminds me of one of my favorite quotes. If you only have a hammer, you tend to see every problem as a nail. If you think just because we learned about a double angle formula that we need to use it every single time, that's crazy. We don't need to use it every single time. You need to be smart about when you apply this and when you don't. So let's take a look at another problem. Here's another problem. Again, we're solving over the interval 0 to 2 pi. Now, let's look at what we're dealing with. Even though these are both cosine, what worries me is that this doesn't match that. And that's a problem. So I don't think I like this cosine of 2x. I think I need to make a substitution. And I have a whole lot of choices, well, 3 choices, to replace the cosine of 2x. So the one I chose was this one here, because if I'm already dealing with the cosine of x, I think I'd like to keep all my functions cosine. I don't want to introduce a sine into a problem that has a cosine. I'd rather not mix the two. So now I have nothing but cosine. I have everything to one side. I'm going to rearrange it, and I'm going to factor it. Now, if you need to factor this using U substitution or blob substitution, do that. But this thing factors. And again, anytime I multiply 2 numbers together to get 0, you know one of those numbers has to be 0. And you've got to play around with each of these until you isolate the cosine. And there we go. We've isolated the cosine. Now we go into our unit circle. We know the cosine of x is a half here at pi thirds and down here at 5 pi thirds. We know the cosine of x is -1 straight out there. And since we're solving over an interval, we can say x is pi thirds, pi, or 5 pi thirds. And that's our answer. We made a substitution because it was the right thing to do. Our inner functions, the stuff inside cosine, didn't match. I wanted it to match. One last example for you. Here you go. Now again, you'll notice that this doesn't match that. And that's going to be a problem. Even though I have sine squared, even though I could make a Pythagorean substitution, If I made that Pythagorean substitution, we would still have an x in this batch, and this would be a 2. They don't match. So that cosine of 2x, I'm going to get rid of it. And now I need to be smart about what I choose as the replacement. I notice I have a sine. Well, I think I want to keep sine squared in this equation. So that's the replacement I'm going to make. So now I have nothing but sine squared. I'm going to clean that up. And you know, this takes a little work to clean it up. And I eventually get down to here. Now you may need to pause the video and do a little work to get down to there. But I'm not ready for the unit circle. To get to the unit circle, I've got to take the square root of both sides. And by golly, if we're taking the square root, we better remember that plus minus. And we end up getting sine of x is positive 1 or negative 1. And now we go to the unit circle. And I know the sine value is 1 there, and it's 1 there. And so my answer, my value for x, is pi halves or 3/2 pi. And that's how you need to attack tonight's problems. You need to think about, do I need to use the formula? And if you do, and it's a cosine, you have a choice. Make a smart choice. Good luck.